All right, I think we are live. Hey everyone, how's it going? Can you guys see me? Just confirm once in the chat section and we will proceed. So the problems will be pasted on the Discord server. You can join that from this link. All right. Thanks, Frank. So how's it going? How's the weekend going so far? Sunday is ending, huh? Winter is coming. Uh, all right, so we have a bunch of people live. I will also open my mobile once so that I can see how does the live stream look. All right. Cool, guys. So let's start with the speedrun. I'll be posting all the LeetCode problem links in. Okay, so I need to move this banners, right? It's too big and it's occupying the screen a lot. So let me move that to the down. Probably this is better. Okay, so this is the Discord link. Hopefully now you can see it. And we'll be solving LeetCode problems. Problems will be pasted in the Discord server. You can join it from here. And let's start with the session today. So LeetCode, problems at all. We will be doing more arrays, strings, medium problems. Like that's where we left in the last time. So status should be, difficult should be medium. And we can start from why are these problems? Is this logged or what? Okay, so one is subrectangle queries. I think it's about matrix one. Looks like we have done this in the past, so I'm not doing that. This looks interesting. Let's open this one. Minimum number of operations to move all balls to each box. Okay, what's going on? What is OP in the chat section? What is this? I started seeing this OP thing when I was when I used to play Among Us and I used to see some live streams. I had a lot of people. I used to see that if someone performs really well, they say OP. But what is this going on? Like we are a bunch of coders. What does OP have to do with us? Anyways, this is something which you can explain me probably. What is OP for a programmer? Is it good? Okay, so Rahul is saying, please attempt June 12 LeetCode challenge. I mean, do you want me to attend a LeetCode challenge? Okay, we can do that. It will already have few problems. June 12 LeetCode challenge. Let's see. Oh, okay. Rahul, do you mean what is June 12? You mean the last problem? This one, minimum number of refueling shops? Not sure. Overpowered. So, oh, okay. OP means overpowered. Well, thanks. By the way, I think now there won't be much of lags in the stream. I think I fixed my OBS setup and I'm really happy that the electricity is also there. All right, people are saying speedrun. Yeah, all right. Enough talk. Let's get our hands dirty. All right. So this was the problem that we had decided to do. I'm pasting in the Discord. First problem link is pasted. Probably you can do it faster than me. Let's see. So you have n boxes, right? You are given a binary string boxes of length n, where boxes I is 0 if the ith box is empty and 1 if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to box j if the absolute difference is 1. So basically left and right one. Now it's saying that after doing so, there may be more than one balls in some boxes. Now you have to return an array answer of size n, where answer I is the minimum number of operations needed to move all the balls to the ith box. All right, so this is interesting. Initially you had 110, and it's saying that to move all the boxes to the first box, you need one operation, which is true. You move this ball to the left, and then the first bag is having first box is having all the balls. Similarly, for this particular box, in one operation, you can move all balls over here. The ball from the first box can be transferred in one operation to the right, and that's working. Cool. For the 0, 1, this one will take one operation. This one will take two operations. So therefore, the answer is 3. Similarly, for this one, to transfer all the balls to the first one, this is 2, and then this is 4, and this is 5. So that becomes 11. So it's quite straightforward. If you want, so how I visualize this is, and this is speedrun, man. I don't have to explain you. Anyways, ith box. Let's calculate how many operations. Okay, well, let's see. For j in range 0 to n, right? Or shall I code in Python today? Let's actually do that. This one will code in Python. Python 3. All right, perfect. I am going to get so many indentations error. I just messed things up. This does not work. Let's do it this way. Right. Ith box, how many ops for j in range 0 to n? What you can do is answer plus equal to the absolute difference of j minus I, right? And you only have to do this if there is something on the, if there is any ball on the jth number. So if box is j, right? If box is j is a 1, only then you need to do this kind of thing. So the ball at jth box will take j minus I steps in absolute sense to reach the ith box. So this is for the current box, the ith box. These many steps are needed. So initially curve was 0, and then you did this, you know that. And now you can say that for overall minima, now you want to append that to your return answer. So answer dot append curve. And your answer is initially empty. And now this can be a for loop. That's it. So this is our pseudocode as well as what we'll be submitting. So let's actually do that. So answer is initially empty for I in range 0 to n. What is n? N is length of boxes. Current is 0 for j in range 0 to n. If boxes j is 1, curve plus equal to absolute of j minus I. Even if j is I and there is a ball over there, the difference will be 0. So no corner case, nothing, everything is sorted. This looks good. We can simply return the answer here. Let's try to run this now. I didn't define n. Okay, so this is. So let's submit. So we'll get time limit error, I think. Oh, it worked. It took a lot of time because it's Python, but the time complexity over here is order n square, right? It's order n square right now. Can we do better, guys? So n is 2000. So right now the time complexity is order n square. Can we do better? Can this be done in better time complexity is the question. So let's see how will that work for current number. Um, all right, so this can be done better also. Like for example, let's say that I is 13. For the 13th index, what do I want to do? So for every j, so there are two types of j's. One j which are to the left and one j which are to the right. So when the j is less than I, so whenever j is less than 13, I am essentially adding I minus j1, right, plus I minus j2, right? So what I need is the sum of, I can actually make this as 2 times I minus the sum of j1 plus j2, right? So for every index, if I know the sum of indices which have a 1, and I know their sum, and I know how many of them exist, then I can simply calculate this in order one time. Similarly, for all j which are to the right hand side, I can similarly, the formula will be j minus I, right? So j1 minus I, then we will have j2 minus I. So this will essentially become nothing but j1 plus j2, j1 plus j2 minus 2 times I. Make sense? So what is this 2? This is the number of ones to the right hand side. Over here 2 was the number of ones to the left hand side. What is j1 plus j2? It's the sum of indices to the left hand side which had a 1, and this is the sum of indices to the right side which had a 1. Right? I think it makes sense. Sure. So, okay, so a bunch of people are saying use C++. All right. Okay, let's do C++ then. I'll cut this, go to C++, and we are back. I felt that Python would be comfortable to you guys, but okay, it's public demand. All right, let's see. How do I do this now? So for int I equal to 0, I is less than n, I plus plus, I'm calculating the answer for current. The sum of, so the count of ones that can be easily stored, right? If your, so that can be in a simple variable. So if boxes I is a 1, I can say left 1 plus plus, or left count plus plus. What else can I do? Initially, I can know the total count of ones that can be calculated easily. So the right count would be nothing but total count minus the left count minus, actually that's not needed. Let's see. So left count will give me this too. Right count, I am getting by total count minus this. So I also have this now. I is already known to me. I now need j1 plus j2 and these sums, right? So let's actually also calculate that sum. So you can have left sum of indices. It's initially 0. And we can also do left sum plus equal to I, right? Similarly, I can have a total sum. So this is total count. We have left count, um, count of ones. And this is sum of indices where it's a 1. All right. To be honest, you should use more meaningful names. Like this could be better renamed as left count of 1, maybe something like that. But anyways, this makes sense to me. So and it's a speed run. I'm not sure why I'm really solving problems really slow. Okay, anyways, I'm iterating on the indices. What is n? N is boxes dot size. Uh, Essentially, what I want to do is I want to do answer dot push underscore back the current answer, which would be sum of this and this. So there will be two paths, left and right, and I'll be pushing left part, so left plus right. I'll make this do not disturb until this evening. All right. So answer dot push back left plus right. What are left? So these are the contributions of the left and right parts. Left, as we are seeing over here, it's nothing but um, so left count times I minus the left sum. That's the left contribution. The right contribution is similarly calculated by uh, this thing, which is the right sum, and then we do minus right count times I. All right. So far, so good. We have not calculated the right sum. Let's also do that. Right sum is total sum minus left sum. Now, one thing is whether this line should be over here in the starting or at the end. I think it's better to put it at the end. I'm not sure. I can reevaluate that later. Right now, my intuition was saying to put it at the end, so I've done that. Let's actually now pre-calculate the left count, the total count and total sum. So that can be easily done. All that uh, involves you to do is nothing but iterate like this. And then if the boxes I is 1, then you can do something like left count plus plus and total count plus plus, and then total sum plus equal to I. So yeah, this is what I was planning. And since I'm doing this later on, the current number contribution will be on the right side, but that doesn't matter because the right count and right sum, they will cancel out each other. Exactly. So yeah, this looks good to me. What is answer? Answer is vector of int answer. It's initially empty. You do over here whatever you need to do, and then you return answer. All right, so let's have a look if we can get this, like if it's working without any compilation errors. It's a good win. So n left count, left sum, total sum. This should be 0. Total count plus plus and total sum plus equal to I. All right. Now I'm iterating on the indices. The right count is total count minus left count. The right sum is total sum minus left sum. Okay. And boxes I is 1, left count plus plus, left sum plus equal to I. That's fine. Now I am saying that left count times I minus left sum, right sum minus right sum. Yeah, it looks like it should work, and I'm pushing back left plus right. Let's actually try to run this code. If this works, guys, I'll take a 1 minute break and I'll be back. Voila. From 5,000 milliseconds to 8 milliseconds, right? Real good, huh? All right, guys, I'll be back in 2 minutes. Alright guys, I am back. So where were we? Um, yeah, you guys can see me, right? Let me know in the chat section once. Hey guys, I see there are so many, like, no one is liking the stream. Come on guys. If you are still watching and enjoying, make sure to hit the like button first. This is not acceptable. We are solving bunch of LeetCode problems on a Sunday evening. We need some motivation. Make sure to hit the live stream. Hit the live stream. Come on, man. What am I saying? Hit the like button, guys. All right, man. This live stream is not going really well, huh? We are really slow. I mean, I'm also a bit sleepy. I'll probably change the title of the live stream. It should be a chill Sunday stream. It's not really speedrun. Like, I think we are live for 30 minutes or 20 minutes, something like that. And only one problem. Anyways, let's see if we can solve more problems. All right. So this one is done. What is the time complexity now? Well, we have significantly improved on that. Order n time complexity. And what about the space complexity? Well, we are not using anything extra. We are like order one auxiliary space. We are not using any kind of DP or pre-processing vectors. Everything is happening just by four extra variables. Order one auxiliary space. All right. Yeah, I would call it a medium problem if you want to solve it like this. So we have done one question. Let's move on to other thing. Deepest leaf sums. Okay, we can do that. Is it about binary tree? All right. So given the root of binary tree, return the sum of values of its deepest leaves. What do you mean by the deepest leaves? Over here, 7 and 8. Okay, 15. Uh, Given the root of a binary tree, so we have this structure, we have left, we have right, empty constructor, which initializes the value as 0 and left and right as null pointers. All right, cool. So deepest leaves, first you have to mark the leaves which are deepest, and then you just want the sum of that. So how should we do this? So the thing is, you can't really use recursion over here, or can you? Um, so the thing is, you cannot use recursion directly, because if I want to calculate the answer for this root node, it's not really fair to say that let's calculate the sum of deepest nodes in this subtree, the deepest nodes in this subtree, and then just sum it up. Because it might happen that the deepest node of left subtree is not really that deep, and the nodes in the right subtree are really deep. Because of that, you don't actually need the contribution of left. So that kind of scenario might happen, if it makes sense. So if the deepest nodes in both subtrees are same level, both are equally deep, you can you can do the recursion for the left and right, and sum it up and return it. However, if that's not the case, then you can do either left or either right. So you can do recursion, but it's not like always the same recursive formula. It's not always the sum of left and right. It can be the sum of left and right. It can be the sum of only left. It can be the sum of only right. It depends on what is the uh, depth involved in each. Okay, so I have one one thing which we can probably do is, instead of having simply int, we can have pair of int, and let's call it get deepest and get deepest sum. So it returns the depth as well as the sum. So let's call it get depth and sum. All right. So this is what I'm saying. If we have a function like this, and we will write this later, but if I have something like this, then it's quite straightforward, right? Let's see how to do this one. I can use that to get left depth, comma left sum equal to get depth and sum of root left. Similarly, I can do that for right. And then I can say if left depth is right depth, then return sum of both. Else, what we can do, if left depth is greater, then we can return the left sum, or we can return the right sum. So now we have to implement this. And how do we do that? So if root is null, you can return, so first thing is the depth, so 0, 0, right? Otherwise, let's see. So this logic will also go in this function as well. This has to go here also. Okay, so let's see. So while we are returning, we need to also return the correct depths. So the depth will increase, always increase by 1, right? Over here, and over here. I'm not sure if this is going to work, but I thought that this will work. If root is null, return this. Go over here recursively. So the thing is, when we are at 7, it should return 7. And that is one case that we have not actually handled over here. So let's add that base case as well. If root left is null and root right is null, we want to return, and this should go below this. We can return depth is 1, and we can return the root val. And over here, oops, and over here, now we don't need all this thing. We can simply do something like return get depth and sum of root, and then dot second. So we are getting 15. Let's try to submit. Oh, okay. So we have an interesting problem. Sorry, we have an interesting comment from 𝗜𝗡𝗢𝗓𝗓. Gaurav is saying, you have seen those problems, don't act smart. Okay. This is a new Chrome profile. This is a new account. I don't remember anything. I can't see what I have solved. And you can also check my submissions over here if you feel that I solve problems before and come over here. You can go ahead, have a look at this. Each submission that I have over here is done on the live stream. I'm doing this to be better, Gaurav. Gaurav. Gaurav, I'm doing this to be better. Um, so, guys, this was also like I think it's a good problem in the sense that you have to think how to use recursion. But it was a good problem. Yeah, I would again say it's kind of medium because it might confuse a lot of people how to implement this. But it was really good. Can you hear the sound when I'm chewing? That would be awkward. I'll have to mute myself whenever I have to chew otherwise. Harsh, please don't spam. Harsh, please don't spam. Sudhir, please don't spam. Guys, please don't spam, otherwise I'll have to keep you on a timeout. Thanks, Sudhir. I heard your message. Thanks for the. Uh, can you explain? Can you do same problem iteratively? I don't want to. It's a speed run. Let's move on. So, oh, I didn't paste the problem link in the Discord. Damn it. Is anyone? I think you guys are smart, right? You are looking at the screen, you're seeing the problem, you're Googling, and from Google, you're going to the link, I think, right? Everyone is smart these days. All right, so I've pasted the second problem link as well in the Discord server. And now I'll be pasting another link. Let's see. Let's refresh this page once. Okay, so we have to solve these two. Um, Group the given people. Looks interesting. Find center of star graph, find nest area between. I don't like geometry problems. Query on a permutation with key. This can be interesting one. So let's solve these two problems. I'm pasting the link in the Discord again. So the problem link is pasted in the Discord. Where is Discord? It's right over here, right? So group the people given the group size they belong to. There are n people. You're given an integer array group sizes, where group sizes I is the size of the group that the person I is in. For example, if group size is 1 is 3, then the person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group of size. Okay. Each person should appear in exactly one group, and every person must be in a group. If there are multiple answers, return any of them. It is guaranteed that there will be at least one valid solution. So when it was having something like this, it was saying that uh, okay. So these are the groups. There is one group which has the person 5, fifth person. and as you can see, the fifth person was having a group of size 1, so he was alone. So that's why 5 comes alone. You can see that over here 0, 1, 2 there is another group, and 3, 4, 6 there is another group. Why? Because 0, 1, 2 it's a group of size 3, and as you are seeing 0, 1, 2 indices are saying that it's a group of size 3. Again 3, 4 and 6 is also saying that we are in a group of 3, and that's why we have something like this. So the thing is, whenever you have so the thing is, if there is in group sizes we have 7, it means that there is some person, right, which is in a group of size 7. So 7 will occur at least 7 times, right? To be honest, 7 will always occur in multiples of 7, because as you can see 3 is occurring how many times? 6 times. So 3 occurs in a multiple of 3. 6 times means 3 star 2, which means that we have two groups of sizes 3. And all right, so for every group we can actually have, yeah, we can do something like that. So I'm saying that for every group size I can map that to how many groups of that size we have. So in this question, I will map 3 to 2 because we have two groups of size 3. So the key is group size, and the value is how many times, how many such groups exist. So this will always be in a multiple. So if we have 7, 7 will occur 7 times or 14 times in the group sizes array. So because of that, I can easily find out this thing. I can build this thing. Similarly, 1 will occur 1 time. And now once I have this thing, I can use this to basically do the allocation thing. So how do I do that? So from here, I see that there are two groups of size 3. Okay. Uh, I am having one implementation idea, but it would be a bit like I feel that there should be some easy way to implement this. So I'm thinking of something else. Okay, so we have a lot of comments. You should get some mods to regulate the chat. Yeah, I do need that. Can you start a series of mock interview videos? Thanks a lot. I have learned a lot from you. Thanks, Satak. Thanks for the compliment. All right. So I'm thinking of some better way to do this thing. I'll be on mute and enjoy my dessert, and meanwhile, I'll also think. So one idea, instead of how many subgroups exist, you can store the IDs of people in it. This will be better. So over here you will have 0, 1, 2, 3, 4, and 6. And for 1 you will have 5. And then you can, for every group, if it's a 3, you start, so pick the first 3, make that one group. Pick the next 3, make that one group, right? So you can use this. So you have a map. It maps your integers to vector of integers. And it's about, let's call it people. I'm not sure about the name, guys. I'm like, what do we call a map of group size to? Like in real world scenarios, I don't know what should we call it. I'm calling it people. So people three will give me all the peoples which are present in group size three. People in group size, something like this. Such a big name, man. All right. So now, for int I is 0, I is less than n, I plus plus. What I can do is I can say group sizes of. So this is the current group size. Let's call it current size, and I can say that people in current group size, the current size dot push underscore back the ith person. So once I have built this, what I can do is I can iterate on them. So for auto, I think we can do the destructuring like this now, and people group size. So let's call it um, um, group size, comma people in it. So I'm iterating on that, and now start making groups of group size. So this is the count, and we need a vector of int answer initially empty. And now let's start making groups. So what you can do is for int I is 0, I is less than people dot size I plus plus. So I'm iterating on the people. I can do something like if I modulo group size is or basically I plus 1 modulo group size is 0, then I know that I can have a stop. Okay, so let's have a vector of int current. So I'm making the current group cur answer dot push back current is empty, and over here people I. So I'm pushing all the people that I have in my current group, and as soon as I have filled enough people, I make that, or actually you can say that if this is confusing, you can say if cur dot size is nothing but the group size. So as soon as the current size is same as group size, you push that and then you empty the vector so that you can start filling it again. And this will always be in a multiple of group size. So yeah, this should work. This was more like implementation based. Otherwise the problem was straightforward. What is n? So we got the right for the example test case. Let's also submit and see if it's working. So it's taking 12 milliseconds, but you are using map, which takes extra log n. You can make this unordered map, so it will use hashing and it will take order one time. And this will still work. Probably it will take less than 12 milliseconds. Not much difference. All right. So this is done. I had pasted the link. I think I had pasted the link. So let's now solve the next one. Someone is saying, please don't delete the stream. Yeah, I will not. Advait is saying, bro, you are literally solving very quickly. Thanks. Thanks to hear the good words. All right, let's solve this thing and let's end the live stream after that. All right, so this is done. I'm closing this. Queries on a permutation. Let's actually read the problem first before pasting this to Discord because the likes and dislikes ratio is not that really good. So it's saying given the array queries of positive integers between 1 and m, you have to process all the queries according to the following rules. In the beginning, you have a permutation for the current I, find the position of queries I, and then move this at the beginning of permutation. Notice that the queries I and p is the result common. Why so complicated statements, man? Return an array containing the results. Let's take an example. So queries, what's happening? Given an array queries of positive integers between 1 and m, you have to process all queries according to the following rules. Okay, so in the beginning you have permutation 1 to m. So we were having 1, 2, 3, 4, 5. So this was a permutation. And the first query is 3. Position of 3 in P is 2. Then we move 3 to the beginning of P, resulting in 3, 1, 2, 4, 5. Okay, next we have 1. The position of 1 in P is 1. Then we move 1 to the beginning of P. The position of 2 in P is 2. Then we move 2 to the beginning. What's going on? I equal to 3, the position of 1. I'm not understanding the problem, guys. I'm leaving this problem. Really horrible problem statement. Not sure. Like up to here, it was 3, 1, and 2. And then for this one, okay. Let's see again. Therefore, the array containing the result is 2, 1, 2, 1. Oh, okay. So this 2, 1, 2, 1. So, all right. I think I understood the problem. It's saying that basically we are doing this shifting kind of thing. Like it's saying that shift 3 to the beginning, shift 1 to the beginning, shift 2 to the beginning, shift 1 to the beginning, something like that. And when you're doing this shifting, the indices will change. But at each query, you also need to store what was the position at that time of that number. So initially the index of 3 was 2. So that's why in the result, you have 2 over here. And then once we did the shifting, like we brought 3 in front, it became 3, 1, 2, 4, 5, right? And now it's saying that the next query is 1. So it's saying bring 1 to the front. So it becomes 1, 3, 2, 4, 5. But what was the index of 1? It was 1. So that's why the next element over here is 1 in our result array. So now this is 1, 3, 2, 4, 5. And next query was 2. The index of 2 currently is 2. That's why we have 2 over here. And then we bring that to front. This becomes 2, 1, 3, 4, 5. The next query was, or the final query was of 1. And the index of that is still 1. And we bring that to the front. It becomes 1, 2, 3, 4, 5. And that's why we have 1. All right, so for every, so basically in each query, we bring that to the front, and at the same time, we want to calculate what is its position at that time in the array. Wow. So whenever I pick some number, I bring that to the front. So its index becomes 1. I'll have to think this, but I don't think that it's a bad problem. It's a good problem. I mean, it might be difficult, but I think it's a good problem. Okay, so M is really small. So let's do brute force and make progress in the speed run. Like the brute force is really easy. We do the shifting and every time we can. How can I solve that thing? So the thing is, guys, um, whenever I'm doing a shift, right? So let's say I'm doing a shift from this position. Currently, my query is at this. So I want to bring this element to the front. So its index will become 1. And the index of all these numbers after this will not change, while the indices of all these number will increase by 1. How can we process this information really fast to our advantage? Anyone, any ideas? If not, then I'm implementing the brute force one, which will be like the shifting of these in the worst case can be order n. Let's see if let's do the brute force and I'll probably see the answer for this one if we have something better. So what I want to do is I want a map, which is a map, something like this. This tells me what is the position of post 3 is 10. It implies that 3 occurs at index 10, right? So I'll fill this up, but once I have filled this, let's process the queries. Uh, how do I process the queries now? Well, it's easy. For int q in queries. So currently you have to find answer.push underscore back the index of the current number, which is pos q, right? And now you have to do the shifting. So pos of q will become 1, right? That's the first thing. And then you will do the shifting as well. Okay, I think the CPU is lagging. The heat issue is back. I did not solve it. Sorry, guys. There would be some lag, I think. I'm opening the AC. I think I turned off the AC, and because of that, the laptop is heating again, and you might be experiencing some lag. Okay, guys, I think I'm back. Just let me know once I've turned off the camera for now, like as a temporary fix. Just let me know if you can hear me. Yeah, I do feel that it's because of the external monitor kind of thing. Someone is saying, someone is saying, please donate to buy a better laptop. I mean, just let me know if you have any better suggestions than MacBook Pro. I think it's a matter of some environment, like your environment temperature, and I think it's also about, um, the OBS studio settings. Maybe, like I thought that I fixed it, but I think I need to work on that. It like as we make more live streams, I think it will be better. Hopefully today was still better than the last one. I will check this up. Like I don't think we should have problems going forward. Like I don't want to leave MacBook and go to some gaming PC. I love MacBooks. All right. Anyways, it's it's really weird. You have all kinds of audience. People also give hate comments, but yeah, it's okay, guys. You don't need to donate for me to buy a laptop. If I want to buy one, I can get that on my own. All right. So where were we? Queries. Yeah. Now we need to update or increment the pos values of all numbers from uh, from 0 to q minus 1. No, to pos of q, right? So if pos of q was 3, for example, 0, 1, 2, 3, 4. This is 5, right? 0, 1, 2, 3, 4, 5. Yeah. So if pos of q was 5, we needed to shift these 5 numbers, right? From 0 to 4. So that's what we want to do. So we need to have some reverse lookup. So for int x in reverse lookup, which tells us the number at position, right? So you can have something like at position. So position is telling that actually I messed up. So this is like get the position of ith number. Now I want the reverse of that. So let's actually have reverse pos. So this like you for this you feed in the number and it gives you the index. In reverse pos you will feed in the index and it will give the number at that position. If that makes sense. Okay. So what I want is I equal to 0, I is less than pos q, I plus plus. What I want to do is I want to say the current number is first of all um, reverse pos will tell me the current number, and I'm saying that hey man, your uh, position is going to be incremented by 1 because you're going to shift to the right side. So we have not built this. Let's also do that. And if we do this thing and we have a vector int answer, then I think it should work. I'm not really happy with the solution, right? Because we have a for loop. Not really happy with the time complexity. In worst case, it can be order n square. Okay, anyways, and we can make this an ordered map to use hashing and save some lookup time. Cool. So how do we build this thing first of all? And we also need to update the reverse pos. So the reverse position will be um, the I plus 1, the number is current. Or you can say, like, really confusing, huh? I think this is better. And position of q is 1, and the ref pos of 1 is q. So, yeah, so let's actually do this for the first time. So initially position of I is I and ref pos of I is also I. Okay, so why do I? So we are getting a wrong answer. Why is that? Okay, so it's zero based indexing. So the initial values were wrong. Position of I will be I minus 1 and reverse pos of I minus 1 will be I. And now we can submit this. So of course we are getting time limit exceeded. This solution is really slow. Okay, so we are getting time limit for this one. This is weird. I have I uh, can pos q be 0? Oh no, man. What's the issue? Like, why are we getting time limit exceeded? Do we have an infinite loop or something? Pos q can not be negative, I believe. And even if at max it can be 0, in that case, this won't execute at all. So I do not think that we have infinite loop anywhere. Can m be 0? No, m is 5, right? Why is it getting time limit exceeded? Okay, so we have a bunch of statements in the chat section. And let me also check if I can. Okay, so I'm back with a bit of like, I think I started in the afternoon, now it's like evening, so I have to change the brightness of my camera. It's really dull right now without the light. Let me increase that actually. Um, Let me increase the brightness. Hopefully it's better now. Hopefully the webcam is better, guys. All right. So do we have any ideas? Like we are getting time limit exceeded, it's really slow. So we have a bunch of suggestions. Line 12 and 13. Yeah, this is true. Position of Q should be 0. But I mean, will that solve our time limit exceeded issue? Oh, it did. That's true. We have to use zero-based indexing for the indices. Thanks. Who mentioned this? Thanks, Parth Patel. It's really good when you have a bunch of people watching and they can really save a lot of debugging time. All right, so why is it wrong now? Okay, so this was done correctly. So we have some problem over here, most probably. For the given number, this is the index, and then I'm taking it to the front. Okay. So when I'm doing this, I am overwriting that. I cannot do that. I should not do that. So basically, this should happen at the end. Okay, what were we supposed to do? Let's see. We got this. So this is not having any problems, right? We iterated on all the numbers from 1 to m, and I said that position of current number is this. Yeah, so this is fine. So there's some problem over here. Let's see. We are iterating on the queries. I am saying that the current position of the qth number is given by this. That's fine. And now what I'm doing is I'm doing the shifting. So when I'm doing the shifting, what I want is um, the current number at the current index. It is this one, and all the numbers which are to the left of this, yeah, I'm marking them to the right. That's fine. This is fine. I can do that. Position of current number should be plus plus. If and we do not have duplicates, so that's fine. Current will always be unique, and I'm shifting those numbers to the right hand side. Or just to be safe, I can do I plus one, shift to the right hand side. And then what I'm saying is reverse I plus one is cur, right? Because I'm doing the right shift, the number at the current index, if it was 0, now it's 1, which is fine. And then I'm saying that the qth number, the position of that is 0. This looks fine to me. Yeah, getting 2, 2, 1, 1. So it's saying that when we did the shift, um, so let's actually, is this the sample test case first of all? No. So let's actually see what's happening. 3, 1, 2, 1, right? We had 1, 2, 3, 4, 5. Then it's saying do the shifting. So the array becomes 3, 2, 1, 4, and 5. Right? We did the shifting. Initially 3 was at index 2, so that's why we have a 2. Now the next number is 1. And I'm saying it's 2, right? And it is at index 2, right? Okay, so it's 3, 1, 2. 1, 2, 3, 4, 5 was there. So it should be 3, 1, 2, 4, 5. And when I'm querying 1, it is at index 1. So definitely I should get 1 over here. That's true. I'm getting a 2. What did I do over here? Um, the Q was 3. The position of 3 was something. I iterated on all the numbers. So the position of 3 was 2, so I'm iterating on 0 and 1. And the current number is given by this thing. It will give me, oh, okay. I see. So the problem is, okay, so the problem is when we are doing this shifting, guys, wait, but I have not updated, right? So initially this was 1, and I'm saying position of 1 becomes 1. And I'm saying reverse position is also same. Oh, okay. Ah, damn it. Here is the mistake. We are updating it over here, and then in the next statement we are using it. So this is the mistake that is happening. Like in one for loop, we are updating multiple things all at the same time, which is causing synchronization issues. Essentially, what is happening? I mean, the normal brute force approach also I messed up. I think I'm feeling a bit sleepy now. But so the problem over here is we are iterating in this for loop, and then as we are iterating, we are doing these things, and then again, marking this, which is causing problems. So actually, you can do this after this for loop over here. Why am I complicating this? I'm not feeling good. Like I'm really complicating things. I just had to, update the mappings. Why am I really complicated things a lot. Like I can do it in different for loops, but I don't want to do it. Like it's already getting complicated by using two maps. And I also feel this is not the optimal solution. Chat out. I don't want to do it like that, man. So let's see if we have something else. We can do it in reverse order, right? So if I do it like that, I get the current number and I say that, hey man, your position is I plus one. I'm shifting it to the right hand side. And then I'm saying that the reverse position of I plus one. So this looks promising. It would have been easier if I just maintained an array, I think. So we do not need another for loop. We can do that in like from the right hand side. So we can avoid that overwriting. I mean, it's better if we just do it by using an array, I feel. Like it's already, the time complexity is really bad. I mean, the only benefit of this is we are doing the lookup in order one time. We are doing some time saving over there. Do we have a better time complexity for this one? This is also doing brute force. It's saying that create a permutation list, and then for each I find the position of queries I with a simple scan and move this to the beginning. Looks like we don't have an optimized solution right now. All right, guys, I think I'll take your leave from here. I'll probably go for a walk and rest for the day. I'll see you probably on Monday now. Till then, happy coding. Take care. All the best. And all the solutions will be posted to GitHub, so you can check that out. The data structures algorithms repository. Also, we have a modern CPP tricks repository. For that also, like I think we started 8 days back, and it's having like 200 stars on GitHub. It's really cool if you are using C++ and want to see the new modern tricks which are coming, which help us in coding interviews or competitive programming. Definitely competitive programming for sure. In coding interviews, you might not be able to write so much of code, but some things are really cool. Something like this, which is like JavaScript, like destructuring. That was really cool, and you can use this quite often. So yeah, that's pretty much about it, guys. And if, as you can see over here also, like we have a Hindi YouTube channel, Developer Bhaiya. Make sure you also subscribe to that. If you have not hit the like button of this live stream, please click it right now. And for pictures, you can follow me on Instagram. And for short written content, you can